In this illustration, a function from R to R is defined as this mod of x into x minus sin x, and we have to find out the 1 or onto nature of this function. So let's break it into two definitions. We can write fx equal to mod of x, x minus sin x, where if x is greater than 0, this mod will be open in with a positive sign, so x into x minus sin x. And here, if x is less than 0, we can write minus of x minus sin x. Here, to find onto nature, we can write x square minus x sin x, and here minus x square plus x sin x. So in this range from x is greater than 0, we if we put x is tending to plus infinity, we can say this term is tending towards plus infinity, since x square term is dominating here. So while x is tending to infinity, we are having the function fx value will be at infinity. And here also similarly, if we put a minus infinity, x is tending to minus infinity, we have fx as, while x tend to minus infinity, we have fx value as minus infinity, since x squared term is dominating. So we can say the function is takes plus infinity value while x is tending towards plus infinity, and it takes minus infinity value while x tending towards minus infinity. Or we can say that since this function is continuous, to check it, since mod x is continuous and x minus sin x is also continuous, so the product of the continuous function, we will get a continuous function. So this function takes all the values from its codomain. Since the range is equal to the codomain, and hence we can finalize that this function is onto. Function will be onto. So neglect this options. Option number A will be neglected, and this will be neglected. So now our remaining two options, we have to check 1 nature. So now to check 1 nature, let's differentiate it. For x greater than 0 and for x less than 0, if we differentiate this term, we will get by applying chain rule, x into 1 minus cos x plus x minus sin x, and here we get minus of x1 minus cos x plus x minus sin x. We're all aware about the sin x graph. This is our sin x and this is our y equal to x line. So look here, when x is greater than 0, for x greater than 0, we have x is greater than sin x. Since x is greater than sin x, this term will be positive, and 1 minus cos x is always positive. Since cos x lies between -1 to 1, we get this term will be positive, and this x is already positive in our range. So we can say that when x is greater than 0, we have f dash x value as greater than 0. That means fx is increasing in the range of x greater than 0. And again, in this range, here x is less than 0. In x is less than 0, we have sin x is greater than x. That means this term will be negative. And 1 minus cos x is always positive, and here x is negative we have taken, so this is negative. So negative into positive will be negative, entirely negative, and this term will be also negative. So, and this negative sign remains outside. That means this entire term, which is nothing but f dash of x in x less than 0, is positive. That means when x is less than 0, fx is also increasing in x less than 0. So if we draw the rough graph of this function mod of x minus sine x, we have uh, at infinity we have infinity, and minus infinity we have minus infinity, and if we put x equal to 0 we have 0. So that means in this phase we have increasing function. That means the graph will look like this, and in this case we have also increasing type graph. That means we have to draw like this. That means from this graph we can say that the function is 1 1. So hence both 1 1 and on 2 will be the correct option, and B will be the incorrect option.